Alright, so we actually took the first order derivatives of this in the previous set of notes. If you go look at the previous set of notes, I took the derivative of this. And so I'm just going to go ahead and write those down. So this was from the earlier notes, the 6.1 part 1. This comes out 6xy cubed plus 1 over x. And then f sub y came out 9x squared y plus 1 over y. If you go back and look at my previous video, or my previous guided notes, we got those earlier. Alright, so now I'm going to find the derivatives of each of these with respect to my variable x and then with my variable y. Alright, so I'm going to start here. And so before I get started, I'm actually going to rewrite. Remember, 1 over x is the exact same as x to the negative 1. That way I don't have to use the quotient rule. I'll do the same thing over here with the 1 over y, but I'll do that when I get there. Alright, so now the second derivative of these functions, first with respect to x, and then with respect to y. Alright, so the derivative of this function with respect to x, so 6x y cubed, so the 6 and the y cubed come along. The derivative of x is 1, so it's just 6y cubed. And then this is the part where it's important that I rewrite it. I don't want to use the quotient rule for 1 over x. And so I rewrite it as x to the negative first. And now I can use my power. I'll pull out my negative 1. And then I get x raised to the negative second. And it's fine if you leave it like that. Or if you want to rewrite it as 1 over x squared, that's fine too. I'm just going to leave it. Alright, so there's my second derivative with respect to x twice. And now my second derivative with respect to x, then y. Alright, so if you look, the derivative of this only has one y term, the y cubed. And so that doesn't really matter. It'll zero out. The 1 over x zeroes out. And so I only take the derivative of y cubed, so the 6 and the x come along. The derivative of y cubed is 3y squared, and then if I rewrite that, that's 18xy squared. And this is why it's important to make sure you label it, and that's my x and y. Alright, done with the f sub x. Now I'm going to go over here and take the derivative of f sub y twice. So f sub y, f sub yx. Alright, so again, same trick over here. I'm going to rewrite that as y to the negative 1. Alright, so now the derivative of this with respect to y. So there's two y terms. There's the 9x squared y, and there's the y to the negative 1. Alright, so the 9 and the x squared come along. The derivative of just y is 1, so it's just 9x squared. And then here I'm going to get a negative y to the negative second, which again, you can rewrite if you want to as 1 over y squared. I'm fine if you leave it, though, with the negative 2. All right, now the mixed derivative should simplify to 18xy, but you get there in a different way. All right, I'm looking at this function. All right, take its derivative with respect to x. The 9 and the y come along. I take the derivative of the x part, which is the x squared. I get 2x. There's no x in the 1 divided by y, so that zeroes out, and so it's 9y times 2x, and then if I do simplify that, it does simplify to 18x, if I take my 2x times 9y, and they are the same. Now, you get there by different values, because the order matters, but when you simplify, they turn into the same value, but they don't turn into the same value until you simplify. Let's go ahead and do the next example. Alright, so I'm going to find the first order derivative with respect to x. Alright, so I've got 3x terms. I've got my 4x cubed 5y, and so we get 4, 5y comes along. X cubed gives me 3x to the second, minus 3 plus 4x. Or if you do it the other way, a lot of students prefer I bring down the y squared, take the derivative of 4x, or 4x to the fourth, which is 4x cubed. The 2 will zero out. Alright, if I simplify that, I do want to simplify it because I'm going to take derivatives of it. So I get 12x squared y to the fifth minus 3 plus 4x cubed y to the second. Alright, so there's my first derivative with respect to x. Now I take its derivative twice. It's not y. xy. Alright, so take the derivative with respect to x. So again, the 12 comes along, the y to the fifth comes along, so 12y to the fifth. Take the derivative of x squared, which is 2x. 3 will zero out. The 4 and the y squared come along. I take the derivative of x cubed, which is 3x squared, and then I clean it up. I get 24x y to the fifth plus 12x squared y to the second. Alright, and so there's my second derivative with respect to x. Alright, now my second derivative with respect to y. Alright, so now I'm looking at the y part, so it's important which part I'm looking at. And so the 12x squared will come along. X squared. I take the derivative of the y to the fifth, so I'm going to get 5y to the fourth. Plus the 4x cubed comes along. I take the derivative of the y squared, which is 2y, and then we clean it up. We get 60x squared y to the fourth plus 8x cubed y. Alright, and there's my derivative with respect to x, then y. Alright, so I'm done with the x. And so then over here, I'm going to go look at my y. Alright, so separate it. F sub y first. So taking the derivative of this with respect to y, there's only two y parts. Alright, the 3x and the 2 are constants. They'll zero out. So the y part, my 4x cubed comes along. I take the derivative of the y to the fifth. It's going to be 5y to the fourth. Plus x to the fourth times 2y, right? The derivative of y squared is 2y. And then I'll clean that up before I take my second derivatives. So this is going to give me 20x cubed y to the fourth plus 2x to the fourth times y. Alright, so this is the function I'm now looking at. So I can kind of ignore all my other functions. That's the one I'm looking at. So now I take its derivative with respect to y, and then I'll take its derivative with respect to x. Alright, y first. So the 20x cubed comes along. The derivative of y to the fourth is going to give me 4y cubed. Plus the 2x to the fourth comes along. The derivative of just y is 1, so it's just 2x to the fourth. And again, I will clean it up. So I get 80x cubed y cubed plus 2x to the fourth. Alright, now the mixed one, which I know what it should come out to be, but I get there in a different process. It's the process that we're looking at. So the derivative with respect to y, then x. So again, looking here, taking the derivative of this function now with respect to x, so the 20y to the fourth will come along. I take the derivative of the x part, which is the cube, so I get 3x to the second, plus the 2y come along. The derivative of x to the fourth comes out 4x cubed, and then I clean it up. Cleaning it up should give me the exact same expression I had on the previous one. So 60, right? 3 times 20 is 60. X squared, y to the fourth. 8x cubed y. And if I look at my mixed partials, I do believe they're exactly the same, right? I got there in a different process, but when I simplified, they came out exactly the same. And that should always happen with your mixed derivatives. All right, we'll stop there. I'll pick up the next example in the next video.